All right, so I'm live with you whilst I'm live on Facebook, Instagram, and YouTube. Right, you can check. Those who want to watch from those, you can check on my account. This is the paper we are doing. I've zoomed in now. October, November 2024, paper 2-2. There's paper 2-1, there's paper 2-2 and everything. I like this one because a lot of the questions in here are questions that we have done together, okay? Are from topics that we have done together. So we just want to revise. We'll go through it quickly. For you, this is a good way to test and see how far you are in maths and how far you should practice these last 2.5 months. So this is our first full paper together. Let's go. I started number 1 and it was a sequence. And we saw that for a sequence, you say term ahead, like T3 minus T2 or T5 minus T4. If you want to understand what is going on, you take the 1 in front, -9, then you subtract the 1 ahead. You take this one, then you subtract the 1 before it. So you subtract -3 because that's the 1. Okay, don't make mistakes because of negative. It's -9 minus, then you take this one, which is -3, which is -9 plus 3, because minus is a plus. And we found that this will be a -6. So there is a -6 here. Then we did again with our pencil to find out what's going on. We took this one, -15, minus, then we took this one, minus -9. We want to find out what's going on. It becomes -15 minus becomes a plus 9, which becomes -6. So this is a -6. So anyway, this is what happens. Now, that's how it goes. So we now know that to come from here to go there, you subtract 6. What about to go backwards? Because we want to find this one, so we want to go backwards. To go backwards, you will now add 6, the opposite of subtracting 6. So you say -3 plus 6, which is the same as saying 6 minus 3, which is the same as saying 3. So C is 3. C is 3. Then, to come here, you say this, there is a -6. So you say -33 minus 6. You get -39. So here, this is our K. It's easy, -39. Because we are subtracting 6 to go backwards. So that's just what you had to do for the sequence, and you get 2 marks. And you move on. You don't, listen students, don't stay too long on a 2-mark question. You have bigger fish to fry. Keep going. All right, so this second question had talked about an isosceles triangle. And maths is not mad. When they give you a statement, they expect you to know something about the statement. So here they said we have an isosceles triangle. What do they expect you to know? They expect you to know that the base angles, this is a true statement. So everybody, can you write this, and you should know it from today onwards and forever. For an isosceles triangle, what you must always remember is that base angles, this is the special thing about it. Base angles are equal. Base angles are equal. This is only the isosceles triangle. Only this type of triangle, which has 2 equal sides, and the third one is not the same as the others. So it has only 2 equal sides out of the 3. Which ones are the base angles? The angles opposite the equal sides. Isn't you have 2 equal sides? So go to the equal side and go opposite them. You get this angle theta. Then you go opposite the other equal side, you get this other angle theta. These are the base angles. They are equal. They are the same. So this is automatically 43 degrees without any calculation. You have used the property of isosceles triangles, which says base angles are equal. And now you know, it's so easy. You know how to see base angles. You go opposite the equal sides. you get base angle. So this is 43. Now, can we get x? Yes. How can you get x? You use the other thing that everybody knows about triangles, which is they add up to give you 180 degrees. So now you can find it because you only have one missing side. You will now say, to get x, okay, if you want, you can first say x plus this 43 plus the other 43 should give you 180 degrees. Because a triangle adds up to 180. That is why you wrote this statement. You know that the angles in a triangle, they add up to give. This is property number 2 now that we are using. But this is true for all triangles. They all add up to give you 180. Now to find x, we just say, first add x. This is 43 plus 43. You get 86. So x plus 86 gives us 180 degrees. Now to get x, we'll say 180 degrees minus 86 degrees. And you put it in your calculator, you get 94. So x is 94 degrees. You put 94 degrees, you have found x. You have found x. Now you can go down here to this. Complete each statement. They are asking you now to just check. Give us a natural number. So natural numbers, these, for you to know these questions they're asking you, it is from topic 1, which is types of numbers. You learn about all the types of numbers in topic number 1. Natural numbers are also called counting numbers. These are the numbers we use when we are counting things. When we are counting things, we say 1, 2, 3, 4, 5. We don't start at 0, and we don't have negatives. We don't have anything with a comma. We say 1 person, 2 people, 3 people, 4 people, 5 people, 6. Or when you're counting cars, 1 car, 2 cars, 3 cars. So it's the normal number, the counting numbers. The only counting number here is 24. It's a whole number and it's positive. This is the one. An irrational number. Irrational number, the easiest ones, we always do them, are surds. Surds are irrational. Surd means a square root. When we say an irrational number, the ones that you do is the surds. Let me tell you what a surd is. A surd is a square root that is bad. If you punch that square root in a calculator, you get a bad answer. An answer with many things after the comma. Like root 3, root 2, root 5, root 6, root 7, root 8. These are all surds. If you punch them in the calculator, they give you bad answers. So they are irrational. So just look for root something here, root 3. But they should not give you root 9, because if you punch root 9, you get a nice number, a 3. So yeah, I'll explain more to do with that. I'll explain to you so that you understand what we call square numbers. It will help you to understand these better. Reciprocal of 4. You do this again when you do types of numbers. When they say reciprocal, they mean the flip. Reciprocate is to flip something. So when they say reciprocal of 4, it's like saying flip 4. 4 is the same as 4 over 1. When you flip it, it becomes 1 over 4. So the reciprocal of 4 is 1 over 4. Now we move on. Here is the next question. The diagram, scatter diagram, blah, blah, blah. Write down the number of people in this building. One of the building has 67 rooms. Then now they want the number of people in it. So we want to see when we go to 67, because this is 60, and this is 62, 64. Okay, let me reduce the size. 62, 64, 66, 68. So 67 is between 6 and 8 here. So they want you to then tell them the number of people. So let me tell you what to do on a scatter diagram. When you come to a scatter diagram, you draw what we call the line of best fit. Line of best fit means a line which passes through the points fairly. It should pass through the points nice, fair, and equal like this. Okay? there should be the same number of points on the left and the same number of points on the right. Look here. There are 3 points on top of the line. 1, 2, 3. 3 points on top of the line. And there are 3 points on the bottom of the line. 1, 2, 3, like this. And 1 is sitting on the line. So that's beautiful. So that means we have passed through the center of these points. It's looking nice like this. This is what we call the line of best fit. It's going through the center nicely like this. Now, you can now go, you want to see. They said, write down the number of people. 67 rooms, not 67 people. Write down the number of people. So you go to 67 rooms. You go to number of rooms. You go to 67, 62, 64, 66, 68. So 67 is between here. Then you see where it meets the line of best fit. Oh, well, you don't even need the line of best fit. You can see that you don't even need it. You can see for 67, there's actually a point there. And you can go down to say, oh, for 67, there was how many people here? 72 for 76 people. So it was 76 people. Now, in another building, there are 42 people and 33 rooms. Okay. So now let's go to 42 people, which is here. And let's go to see where it meets 33 rooms. 32 is here. 33 is at the center. You see where it meets the 33 meets here. So you put a point here. Now we can remove our lines. Then they say, plot this point. We have plotted it. Draw a line of best fit. We've drawn it. We've drawn the line of best fit. Now they're saying there are 45 people in a different building. Find the number of rooms in this building. Well, don't worry. Don't read questions hard. Skim. Don't read questions too hard. Don't try too hard. 45 people, you now want number of rooms. So you go to number of people. You look for 45. Don't make it complicated. 42, 44. So 45 is at the center here. We see where it will meet the line of best fits here. It meets the line of best fit here. Then it goes like this. It is 39. Because they told us that there are 45 people. So that is why we went to people. Don't confuse it. When they say people, you go to people. So we got, and we then looked for rooms, and we got 39 rooms. So this is 39 rooms. What type of correlation is shown in this scatter diagram? This is the last one. So you already expect the next time you do this type of question, them to ask you the line of best fit and stuff. You just do this. It's easy marks. To think this is an IG math exam, you can't afford to lose marks on this. This is way too simple. So this is what you do. Now they say find the type of correlation. So there are 3 types of correlation. There is what we call positive correlation. Yes, did somebody call my name? Where? Okay. 29. Yeah, 29. This is good. This is 29. So it's 29 rooms. Good. It's 1 less than 30, so it's 29. Now, well done. Now, the correlations, you have 3 types of correlations. Well done. So if you see such, you should stop me quickly and we'll quickly fix and we'll proceed. There are 3 types of correlation. There is positive, there is negative correlation, then there is no correlation. The 3rd type of correlation is no correlation. Correlation means relationship. Correlation. The word is telling you. Come on now. Don't let me down. Correlation means the relationship. So if 2 things do the same thing together, then they have positive correlation. Positive correlation means you work together. So They are both. When one goes up, the other one goes up. When one goes down, the other one goes down. So they go up together. We did not say by the same amount, but they go up together and down together. This is positive correlation. Negative correlation, it means one goes up as the other comes down. This negative correlation. Let's say you have your axis like this. Negative correlation, you know that the horizontal, it goes up as it moves to the right, right? So if you see things going like this, they will never be perfect, but you see things going like this, is negative correlation because it's increasing horizontally. It's going up and up towards the right, but it's decreasing vertically. It's going down. So this is negative correlation because the points are going down as they are increasing in things. So this is negative correlation. Then positive correlation means they go up together like this, going up together like that. As one goes up, the other one also goes up. Then no correlation, it means they are all over the place. One goes down together, then it goes up together, then they go down like this. There is no correlation here. There is no correlation. So what type of correlation can we see here? You can see that they are going up together. So this is a positive correlation. Okay? Positive correlation. I'm happy you have mastered it. Now, next question. Area of trapezium is this. Well, mensuration, we are not afraid of it. We are not afraid of it. We know that when we read a statement, we convert it to a formula. Area of trapezium is this. So the first thing we do is we put the formula for area of trapezium. Before we look for x, x will find itself. We are not worried about x. We saw the statement we wanted. Area of trapezium is going to be a plus b over 2 times the height, which means it will be a and b are the two sides that are parallel to each other. So this would be x plus, what is b? 9.5 over 2 by the height, which is 6. And the area of the trapezium is 42 square centimeters. So this is what we have. Okay? We can now remove area of trapezium, then put what they said, 42. And so. So remember, there is a statement where you must start from. This statement, area of trapezium is 40. So write it down as a mathematical statement. Area of trapezium, put the formula, then write it like that. Now, we say, let's do it. We take 6 to the other side. It was multiplying. On the other side, it will divide. 42 over 6 is equal to x plus 9.5 over 2. 7 is equal to x plus 9.5 over 2. We take 2 to the other side. 7 by 2 is equal to x plus 9.5. 14 is equal to x plus 9.5. 14 minus 9.5 is equal to x. 4.5 is equal to x. So what is our x? 4.5. Any questions? It becomes very easy. We did not look for x. X found himself. It's because we started at the correct position. We read it in the question. Now, next question. Without using a calculator, then you must work out this. This is a very common one. 2 over 7 divided by 6 over 11. This is the same as 2 over 7. Then we multiply by the flip. That's how you divide fractions. 11 over 6. You multiply by the flip. Which now becomes 2 times 11, 22, over 7 by 6, 42. Which will be 2 into 22, 11, into 42, 21. So it's 11 over 21. Are we together? Final solution. You just multiply and you flip it. 11 now goes to the top, 6 to the bottom, like that. All right. Here, work out the size of the smallest interior angle of the parallelogram. Smallest interior angle of the parallelogram. What do we know about a parallelogram? What do we know about a parallelogram? It adds up to give you what? You say sum of interior angle is equal to the sum of all the interior angles. It's n minus 2 by 180 degrees, which is here. It is, what is the number of sides? 4. So it's 4 minus 2. Then you multiply by 180 degrees, which is 2 by 180 degrees. What do you get? 360 degrees. So now you know that your angles should add up to give you 360 degrees. Are you all seeing, and can you all hear me? Good. So now we have just added to show that our trapezium adds up to give you 360. Now we want to know what second property should we use about trapezium, about opposite angles in a trapezium, to then find the missing thing. So I want you to write in blue. Right. Can you see? Opposite. Now we are dealing the opposite angles in a parallelogram, eh? Let's put them. Write this statement. Opposite angles of a parallelogram are equal. Opposite angles of a parallelogram are equal. And now you can say adjacent ones, the ones next to it, adjacent ones add to give 180 degrees. You must know this about parallelogram. There are two statements. Number one, the opposite are equal. So automatically you come here and put this to be 15 plus 5x. Then you should automatically know this is going to be 132 minus 2x. Now we can now come from here and put the sum. We know that the sum of interior angles is 360. So we will now say 132 minus 2x times 2 on Friday minus here you say minus 2 of 15 plus 5x. So this is what you write. This is going to be equal to 360. We have added all the angles in our parallelogram. And we know they should give us 360 because that's what we just saw. Now all we have to find is x. All we have to find is x. So what do we do? First thing, you can divide everything by 2. Here it will be 132 minus 2x minus, this becomes 15 plus 5x. Then this is equal to 180 degrees. Here you now get 132 minus 2x minus 15 minus 5. This is equal to 180 degrees. So here now, this is an x. All we have to do is find what x represents. And we take who is bigger here. Between 2x and 5x. 5x is bigger. Where is 5x positive? On the right, so it goes on the right. So you now say 132. Then anything with x is gone. It will be now minus 15. Okay. There we go. 132 minus 15 minus 2. Then here, put them. So it's like you say 132 minus 15. Then you take 2x, 5x. It would be, if you want, first of all, you would say minus 180 degrees because it would come. This is equal to 2x plus 5. Can you see it? This is equal to, this is now going to be 2x plus this negative 5x will now become a 5x. So now, can somebody punch for me? 132 minus 15 minus 180. What's the answer? What is the answer, students? Punch, punch, punch. 132 minus 15 minus 180. Punch and put in the chat. What's the answer for this simple one? Negative 63. Yes, we can just use for fast calculations. We'll do that, no calculating stuff. Then you divide by 7, you get negative 9 degrees. This is equal to x. Here, you get your negative 9. It's actually divided by a positive 7 so that you get a negative 9. That's the answer. Are we together? Now we come to this one. Good. Now we come to this one, and we want to find, they said calculate the area of the circle. We want to find area of circle. So, area of a circle is about one thing. Do you know the radius? Which can be from here to here, from here, as long as you get to the circumference. So this is what we are trying to solve. They want the area of the circle, but we need radius, which is this one. This is the one we need. Now, they're saying the area of ABCD is 72 square centimeters. This would be like R. I just say R. Now, since you know the area of the square, what can you find? If you know the area of the square, what can you find? Well, if I were to look at this, what you know is that the square is these sides. You can say this triangle number 1 and triangle number 2. So you can use it to try and find R. This is the game we have to play until we find R, then we'll be rewarded with our 3 marks. So we can say pi R squared. So our job is to find this R here. This R. That is it. We've got to find this R here. Now, what you know is that this distance here is, let's find out. This is half of your square. So if a square has this area, you say area of a square. Well, here it is. Sarah, can you see my screen? Can you see it now? Check my Facebook or my YouTube. Can you check there? And comment. Are you checking? Check and tell me. Can you see it? Huh? Okay, good. Right. All right. Now let's continue. So what were we saying? Here's the thing. Area of a square is equal to side times side, which this is a side, this is a side. So we'll go step by step. Would be saying, which means area of a square. What is the area of the square? 72. This is equal to side times side is side squared. Side plus side, that's when it's 2s. But side times side is side squared. So it's like this. Now, to get this, we take square to the other side, it becomes square root. So square root of 72 is s. What do you get if you say square root of 72? What do you say? What do you get if you say square root of 72? Tell me. What is square root of 72? Should we leave it as root 72? We can leave it, but we can even leave it as root 72. It's 8.5. Is it a straight answer with nothing else after that? Or you rounded it off? No, okay, we don't want the rounded off one. We don't want to round off right now because we had noted the final solution. So we don't round off too early. So just go step by step. You saw where it says area of the square. So write the formula. We have taught you that for these type of questions for mensuration. Anything which is mentioned, write the formula down. Then you can see what you can get. So right now, what you have is what? What you have, students, is you have the side. The side. So I can come here and I can say, hey man, this is root 72. This is root 72. This is root 72. And this is root 72. Well, okay, that's fine. Now, what we need is the radius, which is this distance here. The radius. So if if I can, let me just show you some things. Even if you want to cut your shape like this, there are many ways that you can kill this cat. Many things that you can do. So what we'll be now trying to do is find the radius using a formula of this square. That is what we'll be now trying to do, to find the radius using a formula of the square. So what we'll be saying is this. Let's just try to, let's say this is r and this is r again, and this is root 72, and this is root 72, right? If we want to get area again, all right, or let's do this thing that I can teach you right now, is when you have a triangle like this one, which is isosceles, I'm going to teach you a trick. This is an isosceles triangle. Look at one more trick I'm teaching you about isosceles triangles. Look at it. This is the isosceles triangle. Okay? You should know that if you want to get this here, which we have seen is 2r, because it is r plus r, which gives you 2r. You can say that for me to get, this is, let's just call it a theta, an angle. And this would be 45 degrees because it's an isosceles triangle. And this would also be 45 degrees for this nice isosceles triangle of ours. If I want to find this 72, I would be saying what? If I want to find the 72, remember radius is from here to there. So if I want to find the 72, look at what I'll do. Watch closely. Okay? I would say, I want to find it. This is my radius, r. So I would say, if I take this radius, look at how it works. It works like this. It's a trick which you use even in engineering problems and whatever. You have this angle here. You have this line here, L. You have theta. Okay? You have this line and you have theta. You want to find this x. We say to get x, you say L cos. Okay? To get x, it's L cos theta. L times cos theta, you get this one on the ground. To get this one, which is straightened up, you say L times sine theta. You get the one which is facing upwards. Okay? I don't want to over-explain it. Can you see? Students, can you see? Guys, can you hear me? Yes. All right, good. So for you to get the horizontal one, you start with the slanted, then you say cos. For you to get the vertical one, which is this one, which is upright, again you start with the slanted. But now you multiply by sine. Right. So anyway, we have found this to be here. This diagonal here, this one, from this side to this side. If we calculate it even by Pythagoras, let's just say we calculate it by Pythagoras theorem, I can remove this 45. Let's say we have found this to be root 72. So well done, you have found the side. Pythagoras theorem you can use to find this one. You would say, let's do Pythagoras theorem, another one for those who want to use it. We would say, Pythagoras says, find the hypotenuse. This is the hypotenuse. So you say hypo, which I can call BC or DB. So I would now say DB all squared is equal to this one squared plus this one squared. That's what Pythagoras says. It says the hypo, find your hypotenuse. It's the side opposite the corner of your right angle. That side squared, which is DB, which is the hypotenuse, when you square him, it should be equal to this squared plus this 72 all squared. So you say DB squared is equal to root 72 also squared plus the other side, which is root 72, and you also square it. What do I get? Remember that the diagonal is a radius and another radius. So it's two radii. So we'll be saying anyway, dB squared, or let's now get dB. It is now the square root of, what is this? Or let's keep it dB squared first. Can we first find out what is root then squared? It's 72. Okay, so root 72 all squared is 72 plus root 72 all squared is another 72, which gives us 144. That's dB squared. And you'd now say dB, which you need, is the square root of 144, which you'd say dB will be 12. So, Mr. Man, I know you are 12. But what is dB? It is 2r. So you can say 2 radii gives us 12, which means radii gives us 12 over 2, which means radius gives us 6. We would have found the diagonal. We did the Pythagoras. Let's say we did the Pythagoras theorem because it's a right-angled triangle, so you can do your Pythagoras to find dB. To find dB. Can you see dB? So now you have dB, students. Now let's continue, students. We would say, all right, thank you for giving us dB. Let's find area of a circle because we now have radius. It's pi r squared. This formula you'll be having for area of a circle. So it will be now pi by 6 squared to get area, which will be 6 squared is 36. So you get your area as 36 pi, which you keep it as 36 pi because they say they want it in terms of pi. You say your area is 36 pi. Calculate this square root that they want you to do now. Without a calculator. They want you to do something without a calculator. So let me teach you what you have to do. Okay? They want you to find, this is what we call rounding and approximation. They want you to find the cube root of altogether in bracket 1 plus 10.9 times 0.4 all squared. They want you to find the cube root of all that. 1 plus 10.9, then times 0.4 being squared, 0.4 squared. And they want you to find the cube root of that without a calculator. So this is what we call a topic of rounding and estimation. You should know, how do we change values when we are estimating? Right, you look at what whole number is it close to. What realistic value is it close to? Then you work from there. So this is times 0.4 all squared. So this becomes the cube root of, let's do realistic stuff. 1 is 1 plus 10.9 is actually 11. Okay, times now 0.4 all squared. Anybody can get this. 0.4 all squared is 0.4 times 0.4. Okay, 0.4 times 0.4. What do? You first multiply as if it's a 4, this one. Okay, you ignore the numbers before a comma for the denominator. You pretend it's a whole number. So you would say, oh, should I pretend it's a whole number? Yes. So you are going to, like you're saying 0.4 times 4. Right, so you say 4 times 4, you get 16, 6 carry 1. 4 times 0, that is 0. Plus 1, that's 1. So this is 16. This is 16. Now, you count how many digits you have after the comma for both. Here we have 1, here we have 1. So here we must have 2 digits after the comma, which is these 2. So it will be 0.16. So this is 0.16. So we have changed 0.4 all squared to be 0.16, which means you want the cube root of 12 times 0.16. That's what you want a cube root of. Let's just say it like that. Are we together? Students, can you get it without using a calculator? Are you seeing it? How we round off to things that are appropriate. Values that are appropriate. This 10.9, the 0.4 all squared, and the 1. Can you see? So now you can do it with your thing to say 12 times 0.16. Okay? 1, we have made it 11. Remember that, excuse me, let me teach you something. This is where we went wrong. Remember that we need to do BODMAS. So we need to multiply before we add. So this is where we had almost gone wrong. We would say the cube root of 1 plus, we actually need to say 11 times 0.16. Then we'll add it to 1. So let's do it. What is 11 times 0.16? You can say 0.16 times 11. How do you do this? 0.16 times 11. You first do 0.16 times 10. Then you do 0.16 times 1. You add them together. So 0.16 times 10 is 1.6. Plus 0.16 times 1 is 0.16. You add them, it becomes 1.76. So this is 1.76. So we actually have the cube root of 2.76. This is what we actually have. The cube root of 2.76. So now this is the last method that we would need to have. How you can get the cube root of 2.76. You can even leave it to say cube root of 2.76 because it's only worth 1 mark. Are we together? Yeah. If you want to look for a number where you can cube it to get 2.76, you can look for it. It's still up to you. Now let's continue. Factorize fully. We are on the next question. Factorize fully. Now, when you're factorizing, there are 4 methods that you have to factorize. So for those who have not done factorization, listen closely. You have 4 methods that you have to factorize. When you're factorizing, you have 4 methods. Method number 1 is general factorization. And this is the one you use when all the other 3 cannot work. So method number 1 is general factorization. Method number 2, which you always start with, is called difference of 2 squares. We'll work on it. This is the one you look for first. Okay, I'm going to show you. Then method number 2 is going to be factorization of 4 terms, or let's just say by grouping. Factorization by grouping, which is factorization of 4 terms. When you are given 4 things, you factorize by grouping. In other words, you look at 2 at a time. Then you now have factorization of quadratic trinomials. These are the different types of factorization that you must know. Right. Okay? These are the different types of factorizations that you must know. So when you get a when you're asked to factorize, you check 24x squared minus 9xy. First thing we check, is this the difference of 2 squares? I can see difference means subtraction. So you can see there's a subtraction sign. You say, oh, okay, that's nice. Then are these terms squares? This one and this one. Are they squares? You see that you have an x, which is not squared. So these are not squares. So you can't say this is the difference of 2 squares. So difference of 2 squares, you are out. Because everything must be a square number, which means it must be squared, squared, squared. Or you must be able to get a nice square root for it. Okay? So these x's are not squared, so they are out. And also this 24. But once we see that, okay, so difference of 2 squares is out. Then by grouping, this is out because you don't have 4 terms here. You don't have 4 terms. These are all the factorization techniques. So there's no other technique we haven't talked about. Now you check factorization of quadratic trinomials. Do we have three things here? No. So it's out. So we are left with only one thing, general factorization. What do you do for general? We are doing general factorization. General factorization, here's how you do it. You start by looking at the numbers. What number is common? What number can get into both? You see that there is a 3. It can get into 24 and into 9. Then from there you look at what can get into what letter of the alphabet is there for both this side and this side. What letter of the alphabet is there? You can see there is an X. Now you choose the lower power. On the X's that are there, which one is lower one? 2 or 1? 1 is lower. So that means we are leaving it as well. You take the lower one. So it's like this. Now you say, let's now put things in the bracket. 24 divided by 3, you get 8. X squared divided by X, you get an X. Then you say minus. 9 divided by 3, you get a 3. X divided by X, they cancel. There is nothing for Y, so it will come in. And you are done. So this is actually 3x, and then in brackets you say 8x minus 3y. That's how you do it. You come to this one. Look at your list. You have 4 ways of factorizing. You must know them. General, difference of 2 squares, by grouping, and quadratic trinomials. So first you check, is this difference of 2 squares? Look at it. Check here. You see a subtraction sign. You say, it may be. Then you check, is 63 a square number? Can we get square root of 63? No. Can we get square root of 28? No. We don't know such a number. So, okay, there is no difference of 2 squares. It's out. By grouping, it's out because you don't have 4 things. Of quadratic trinomials, tri means 3. So it's like 4x squared minus 5x plus 6. This is not the case, so this one is out as well. So here we are using general factorization. Again, we are using general factorization. How do you do general factorization? Do you do abracadabra? No. What do? You do it in steps. You do it in steps? Are you sure? Yes, you do it in steps, sir. Are you sure, student, that you do it in steps? General factorization. You want to do it in steps? Are you sure? Yes, sir. You must be sure. How do you do it? You look at the numbers first. What number goes into 63 and into 28 without leaving a remainder? That's 7. Then is there any letter that is common? No, there's no letter. So you open your bracket. 63 divided by 7, you get 9. Then x squared is nothing, it comes back. Minus 28 divided by 7, you get 4. Then y squared will just come as it is like this. Then we say, well done. Well done. But let me tell you now, this is a very common one which they've just given you. Because someone will stop here and think they are done. No, you are not done. Because look now what will happen. This will always come. It's a 2-step one. It always comes. Look inside the bracket. We finally now have the difference of 2 squares in the bracket. Because look, 9 is a square number. Its square root is 3. X squared is a square number. It has a squared. 4 is a square number. Its square root is 2. Y squared is a square number. Its square root is y. Okay. Y squared is a square number because it's squared. Like all these are square numbers. And they are subtracting. They must all be squared and they must subtract. Then it's difference of 2 squares. So now we can use this method for the things that are inside the brackets only. So we still have a 7 outside. Now we are factorizing things inside the brackets. How do you factorize using difference of 2 squares? How do you do it? You do this. You square root the first term. So square root of 9, 3. Square root of x squared, x. Square root of 4, 2. Square root of y squared, y. You square root everything. You square root everything. That's how you do difference of 2 squares. You square root everything. Then you make 2 brackets. One where they add 3x plus 2y. Then one where these terms subtract 3x minus 2y. There we go. And you will now have a very special answer. Very, very good work. So you can now say 7 multiplying 3x plus 2y multiplying 3x minus 2y. and you have done the factorization extremely well. Extremely well. Well done to everybody. Now we go to the next one. Y is directly proportional. This is now proportion. So we are starting a lot of the maths we have been doing lately. These hard maths. Now, this one, everybody knows what to do. You don't read a statement and pretend you didn't hear it. Y is directly proportional. So we have two statements. They can say directly proportional, you just put a fish. If they say inversely proportional, you put a fish again facing the left. Your fish should face the left, but this side you now say 1 over. If they say inversely proportional, you put a fish again, but on the right hand side you now say 1 over. Here you don't say 1 over because there's no fish. Y is directly proportional, so you just say Y is fish, which means directly proportional to what? Square root of x plus 1. So to square root x plus 1. Y fish, square root x plus 1. There we go. Then now we move on. What do you do? So this is the most important thing. You have read the statement. You have converted it to something that we can do in maths. Once you do this, you have to remove the fish and put an equal sign. Remove this fish and put an equal sign. But when you put an equal sign, remember the rule. When you remove a fish and put an equal sign, which you must always do, you will bring a k to the right hand side. You bring a constant. So y becomes equal to k times the square root of x plus 1. We bring a k on the right side. That's how you do it. Well done. Now you've put your k. Now what do you now do when it's like this? You now need to find the value of k. That's your next job. How do you find the value of k? You use the next sentence. We go sentence by sentence. Now we are here at this next sentence. They said y is 10.5 when x is 8. So you now say let y be equal to 10.5 whilst x is equal to 8. So x be 8. So where there is y, what are we putting? 10.5. So you say now 10.5 is equal to k square root of. Now you put 8 where there is x of 8 plus 1. So it becomes this. Now it will become 10.5 is equal to k times the square root of 9, which means 10.5 is equal to k by root 9 is 3. Now you take 3 to the other side. You have 10.5 divided by 3. This is equal to k. Can somebody quickly punch and tell me what is k? What is this guy k? What is his value, this guy k? What is the value? Okay. 3.5. Okay. So 3.5 is the answer. 3.5. This is k. So now, here, k is 3.5. So let's keep going. You now rewrite it. Once you have k, that means you should rewrite. You never stop because you now have k. That's wrong. So you can now write to say y is equal to 3.5 square root x plus 1. We will be so happy because you have removed k. We don't like k. You should remove him when we find him. You should remove him when you find him. So you're doing very well. Very well. So now, can you see? Students, are you seeing? All right. So now, what do you then do? You now go to the last statement. They said find y when x is 1.56. So you just say let x be 1.56. They have told us a new value for x. So y will be now equal to 3.5 square root of 1.56 plus 1, which means y is equal to 3.5 square root of 2.56. Somebody just punch this exactly like this. Tell me what you get. You get 5.6. 5.6 as your y. We move on. So this becomes your y. 5.6. And we move on. You're doing very well. You see? You're doing very well. Now, inequalities. This is another thing which we have done again in class. Inequalities now. How do we sketch inequalities? Sketching inequalities. This is now the topic. For those who have forgotten, you should go and revise. How do you sketch inequalities? We said the first thing you do is you convert everything to be an equal sign. And we also say the other thing which you must do is you must make sure that if you have an inequality that is two parts like this, split it into one. Okay? Don't leave it to be two parts. This is wrong. You never ever do this. Never ever ever do it. Split it. So here we have -3 less than y. Then we have y less than or equal to 2. You have split it. Okay, you took y with this, then you ended up taking y with this also. Now below it, below all your inequalities, so this one is now out. This bad one which is there to stop you from getting your marks is out. Now the next step is make them equal signs, because they are useless like this. They are useless. You only use this to shade. Make them equal signs. Y is equal to x minus 1. Minus 3 is equal to y. Y is equal to 2. Now that you have made them equal signs, now you go and you put these points. You put these. So now, okay, when it says any graph which says y is equal to x, then it puts something after. What you do is you just go to this something, to this minus 1. Go to minus 1 on the y-axis, which is here. You go to minus 1. Then after you go to minus 1, you then start doing y equal to x. So this minus 1 is just temporary. This minus 1 is to tell you where to start. Then now you do the graph of y equal to x. Y equal to x, yes. What type of graph is that? It's the graph that goes corner to corner. So you start here, you go to the corner upwards, and to the next one, 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 going downwards, corner to corner again. Now you can join with a neat line. Okay, here's the neat line. So this is called the graph of y equal to x minus 1. We started at minus 1, then we did y equal to x. Right, now you have minus 3 equal to y, which means y minus 3. On the y-axis, you go to minus 3, and it is the line y minus 3, so it stays at minus 3 like this. So this is the line y equal to -3, or minus 3 is equal to y. Then you have y equal to 2. You go to 2 on the y-axis, then you put a line which stays there like that, at 2. Now, when you are putting lines, there's one thing which I forgot to tell you. You look at the type of sign, okay? This type of sign which has greater than or equal to or less than or equal to, as long as there's an or equal to, this is a solid line. This is again a solid line, but the line y equal to -3 is dashed because this is just a sign. It has no or equal to. It's an inequality sign. So that means this one would come out as a dashed line like this. As a dashed line like this. Great stuff. It comes out as a dashed line. Now you can start shading. You can start shading, okay? This one says y is less than. Look at where y is. The crocodile is not facing y. If the crocodile is not facing y, here they should say, let me teach you now, because you're left. Yes, it is really important to dash the line. If you don't dash the line, you're wrong. It's really, really important to dash the line. If you don't dash it, you're wrong. Now you're left with one step. Look, you have changed them to equal signs. You have sketched the lines. You have sketched the lines. You have put the ones that were dashed and solid. You saw the ones that were solid, dashed, then solid. Oh, you did so much. Now you are left with shading, and shading is nice because when you are shading, you must first flip these inequalities. That's the last part of shading. So you flip it. Here it's facing there. It will now face here. Say x minus 1. This is the one you shade, the unwanted, after flipping. If they say shade unwanted, you shade after flipping. So this is going to be y less than. Okay, it will be now -3. Then the crocodile is facing it, which means y is now less than. This is the unwanted region. Then here y is less than negative or equal to 2. It becomes y is greater than or equal to 2. This is the new one. Y is greater than. These are the ones which you actually shade, because they want you to shade unwanted, which means opposite of wanted. So they want y greater than x minus 1. So you go to the line x minus 1. You are going to shade this inequality which you created, this one. Greater than, y is greater than, which means you are shading everything on top of this line. Everything. Like this. Like this, you shade nicely like this. Then you want now minus 3. Y is now less than. It's now on the less than side. So you are shading below on the new inequality that you create. Don't be lazy, okay? Make sure you make the new inequality before you start shading. You now shade below it. When it says, when the crocodile is not facing Y, if the crocodile is not facing Y, you shade below. So here minus 3, you shade below it. The line Y equal to 3. You are shading below it because Y should be less than it. So you shade below it like this. You shade below it, below it, below it, below it. Now you're left with one thing. Y greater than. The crocodile is now facing Y. Y is greater than 2. So you go to the line Y equal to 2. You shade above it because now you want above. So you shade above it, above it, above it, above it. Like this. So you are left with this region which you call R. This is the one which is wanted. You have shaded the unwanted region. Now you get your 4 marks. Why? Because you drew the straight lines which they wanted and you shaded. How did you draw straight lines? You made them equations first. Right. Good job. Now you come here. Graphs. Find the acceleration. So, speed time graph. Everybody should know it from today onwards. Speed time graph only gives you 2 things. It's the best graph. The speed time one is the best and the last one you do. It gives you 2 things. Okay, there are 2 types of graphs: speed time and distance time. Distance time is useless. It only tells us one thing. Speed time is the best. It tells you 2 things. Number 1, speed time graph, the graph called speed time. It can tell you distance, and also speed time graph can tell you acceleration. So speed time graph can tell you 2 things: distance and acceleration. On the same graph, yes. Distance is just these things that are under the graph, the areas. So you find the area if they ever ask us for distance. Speed time graph can easily do it. It's about areas. But acceleration is not areas. Acceleration is not areas. It's gradient of it. Gradient. Acceleration is the gradient, which we know you find it by saying change in y over change in x. This gives you acceleration, is the gradient. Change in y over change in x. This is acceleration, change in y over change in x. So the first 10 seconds, all right. So we pick a point. This point becomes x2, y2. Then you pick another point here. It becomes x1, y1, like this. Right, now, what is it that you do? You do change in whatever change it, which means y2 minus y1 over x2 minus x1. What is your y2? Students, you can do this. This is point number 2, and this is point number 1. Okay? So that means the y, this is the y-axis, obviously, this is the x-axis. The y for point number 2 is called y2. This one. It's y2 because it is the y at point number 2. The x at point number 2 is called x2. This is way too easy. If it's at point number 2, everything is 2, 2, 2, 2, 2. Point number 1, everything is 1, 1, 1. So this is y1, and this is x1. X1 is 0, y1 is 0. So let's do it. What is y2 minus y1? Y2 is 20 minus y1, 0 over. X2 is 10 minus x1, 0. So this is what you do. So you're going to say acceleration is equal to the grad, which is change in y over change in x, which is y2 minus y1 over x2 minus x1, which is 20 minus 0 over 10 minus 0, which is 20 over 10, which is 2. So this is 2 meters per second squared. Calculate the distance. We know that we can find two things on this graph. Somebody will say, sir, why are we doing this chapter in physics, in maths, I mean? Yes, this chapter, only this part, the graphs, they come in maths, okay? They come in maths. It's called kinematics. The maths part of motion, it comes. So anyway, here we'll do this. We would say calculate the distance. Total distance in 17 seconds. That means they want for the whole thing, because 17 seconds is here. So they want the whole distance, this whole thing. Well, that's fine. What shape is that? From 0 to 17, we go through the whole graph and we see the whole shape of this graph, everything underneath it. Everybody can see that this is a trapezium. For all those who have done maths can see that it's a trapezium. These two sides are parallel to each other. Then this becomes our height, because it's nice and it is a perpendicular thing. So this becomes my A, this becomes my B, this becomes my height. And I'll say now distance is equal to area. And it is area of a trapezium, which is A plus B divided by 2. Area of a trapezium, everybody should know, then times height. A and B are the two parallel sides. Now, what is A? A starts here and ends there. This is the A, which is from 10 to 17. That's 7. So it's 7 plus B is the whole thing. This is B, the whole thing, from 0 to 17. So it's 7 plus 17 divided by 2. Then you multiply by the height. Height is from 0 to 20. So you multiply by 20. This becomes 24 over 2 by 20, which is 12 by 20. What is 12 by 20, everybody? $240, right? Meters. So anyway, you get your 3 marks and you move on. You get your 3 marks and you move on. Anyone with a question? Who has a question here? Students, who has a question? Is there anyone with a question? Now, here, no one has a question? $10. Okay, I'll wrap up just now. I'll do the 4, 15, and 16. Then I'll send you the others in bits and pieces, okay? Clips, one by one, the questions just into the group so you can finish it off. We have to finish the paper though. So anyway, this becomes, now we are doing an interesting question on exponential increase and exponential decrease. Because here you are now being told that at the start of an experiment, there are 40,000 bacteria. The number of bacteria increases at a rate of 15% per hour. Calculate the number of bacteria after 3 hours. Only worth 2 marks. Only worth 2 marks. Right, now, let's put, okay? So if they say the number of bacteria increases at a rate of 15% per hour, you say to me, there is no word which says exponential here. So where do you get exponential? If it says At the start of an experiment, you have 40,000 bacteria. Then the number of bacteria increases at a rate of 15% per hour. Then they say calculate the number of bacteria after 3 hours. What in here says exponential? If they did not say exponential. Now look here, students. Let me tell you something. Exponential does not always be, it's not always written to say this is an exponential increase question. It doesn't ever say that. But you should know that it's increasing by 15% per hour. They did not say 15% of the original. No, they didn't say that. They just said it increases by 15%. So after 1 hour, it increases by 15% of what is there. It increases by 15% of what is there. That is what we mean by exponential. It is increasing by 15% of what is there, because it says per hour. They didn't say the whole 3 hours it increased by 15%. No, per hour. So each hour, there's a 15% increase of what is there. That means this is exponential. All right, good. So now let's go. Exponential increase questions, when you're solving them, student, when you're solving exponential increase questions, you use it's like a formula of interest. So can everybody write this, because I need to teach you compound interest, everybody. Final value of, let's say, final amount. Final value, final amount is the same thing. Is equal to initial amount or initial value. Then, like principal, when we say compound interest, we say principal, then we say 1 plus r, which is the same thing here, to the power of t, or number of years. Here we say to the power of n, whatever the time is. We don't care whether it's in years or what, but this is what you do. So you'd say to get the final amount is, what is the initial amount? 40,000. Then you multiply 1 plus, what's the rate? 15%, which is 15 over 100. If you want, you can actually say, make sure the rate is divided by 100. Okay, it's 15%, which already means it's over 100. So then you say to the power of 3. This is what you do. And you just get your answer. You'll be done. So you can say 40,000, for those who have calculators. 40,000, then you say 1 plus, this is 0. Moves twice, whatever. 0.15. And this is to the power of 3. What answer do you get here? 40,000 multiplying 1.15 to the power of 3. 1.15 to the power of 3 means 1.15 times 1.15. Then you get an answer. Then you say times 1.15 again. $60,835. 60,835. Now, Venn diagrams. So let's do Venn diagrams. We've talked about them before. Venn diagrams, the secret is this. Make sure that everything mentioned is already given. Here you are told that 75 people. Okay, this Venn diagram is quite easy, by the way. I'll explain more for a Venn diagram question which they don't explain. This one is only worth 1 mark. And they said, what is the probability? A person is chosen at random from those who have a car. Those who have a car, yeah. Those who have a car, how many are there? It's all these. These are all the people that have a car. Total of 60, because C is for car. So, find the probability that this person also has a job. Find the probability that if they take from the people that have a car. So, listen everybody. What are we doing? A person is chosen at random from those who have a car. Number of people who have a car are how many? 60. Now, find the probability that this person has a car and has a job. Probability of car and job. Okay. How many people have car and job? 51 over how many people are we choosing from? This is the most important thing. The first statement tells you where you are choosing from. You are choosing from people who have a car, so there are 60 of them. We've seen that. Now you are choosing what? That's the next statement. Next statement now tells you what you are choosing. You are choosing that this person also has a job. Basically, you are choosing the probability that this person has a car and also has a job, which is this section. These are the people there, but you are choosing from 60. So this becomes, what is the answer? 51 over 60, what do you get? It's what? 17 out of 20. Is that what you said? "51 over 60 can be reduced to 17 out of 20. So this becomes 17 out of 20. Anyway, you are done. All right, so we still have more things. We still have more work. But I'm going to send you as clips, piece by piece. I'm proud of what you've done. You have made me so happy. This is the beginning. We do past papers, a lot of them daily. So I'll send you with the things that I want you to do. Don't worry. I'm going to send them to you, the information. Okay? There's a lot of work happening behind the scenes. So yeah, I got you guys. Don't worry. Anyway, you've seen a lot. I wanted you to see more, which is this. We've talked about this. So I wanted to do these questions as well. And enter and all this stuff. Here, perpendicular bisector, we've talked about it. Here, we've talked about similarity. I wanted to answer this question. So yeah, it's good. It's a lot of questions to do with things we have done. So we'll do a lot of papers together. I'll polish you up on some things like the things to do with the circle, things to do with the circle like this one, and I'll see where it goes. So for now, can you go and do? Listen, I'm giving you an assignment. October, November, 2024, paper 2-1. I'll send it to you guys in the group. You do it tonight and you submit tomorrow. Okay? Deal? Are we together? Everybody.